Hey there.
Feel free to hang out the rest of the time if you want to. We love having you. It's great.
Okay. Thanks, everyone. Bye-bye.
Thank you. Bye.
Super excited to dive in. I'll just be lurking in the shadows if you need me, but I don't think you will. You're in good hands. So I'll leave you to it, and best of luck, and I'll be watching. Thanks.
Thank you.
Thank you.
Great. So because we don't have any break between the session right now, so I think we should start in like a minute ago. So let me double check everything if we have everything set up and working. Hello, Randolph. Good to see you, my friend.
Hi, how are you? Yeah, likewise.
I'm good, thank you. So yeah, we can hear you, we can see you. That's great. So if you are ready, let me introduce you a little bit maybe, and we'll start, and I will hand over to you, okay?
Can you just
So,
see if you can share your slides, Randolph?
Oh yeah, so forgot
If you
about
need
that
to.
one.
Of course,
cool.
of course I
Yeah.
can. Yeah.
Awesome.
You should
Fantastic.
be able to see that.
Okay.
Yeah,
We can see it now. Thank you, Daniel. Thank you, Daniel, for reminding this. Great. So yeah, so Randolph is our consultant. I think we met like a few years ago during the Secure Bits in London, or maybe it wasn't London, but during the Secure Bits in person.
I think it was Manchester, but yeah, it was
probably yeah. So Randolph is a professionalist around the secure server, and probably not only, but he's a consultant, speaker, and author from Calgary, Alberta, Canada. They specialize in performance optimization and disaster recovery best practices. Started working with probably secure server since version 6.5. Correct me if I'm wrong.
That is correct, yeah.
Yeah, so Randolph is non-binary and uses singular they pronouns. So please remember that. And also, and that might surprise you because it surprised me when I was checking a few things yesterday. They are an actor and producer and director. So I was really surprised. If you go to on the IMDb database or portal, you will see the profile in there. So yeah, that's it for me. Over to you, Randolph. Thank you very much.
Thank you, Camille. It's good to see you. I'm very pleased that you're my moderator today because we have a bit of history together, a good history. And I'm also pleased that you're a fellow MVP. I'm very happy when new people become MVPs, and I know it's been a while for you, but I'm always happy to welcome new people into the group. So I'm going to take it away. Today we're going to be talking about your GroupBy, a practical look at temporal tables. I have done presentations on temporal tables before. These slides are going to look similar if you've been to one of those sessions before, but the demonstration at the end is quite different. And except for right now, I'm not going to mention Back to the Future because that's my favorite movie about time travel, and that was the whole premise of the presentations before. But this is a more practical approach, how it relates more to you in your day job. So let's get into it. I am a Time Lord because I love Doctor Who as well. So if I click on that screen, we're going to talk about the code of conduct. I'm sure you've already seen this if you've been following other sessions as well. I just watched Kevin's session, which was always interesting. I love hearing from Kevin. I always learn something new when I hear from him. The quick version of the code of conduct is that it's harassment free. If we treat each other with respect, everybody's going to be cool. And you've already seen this. There's no harassment. Please look at the code of conduct at the bottom. I have to abide by this, as does everybody else. So it's great to see that there's a code of conduct at all. You've also seen this slide. If you've attended other sessions, there are a number of sponsors that make this possible. Thank you to Minionware, to Redgate, to SolarWinds, to SQL Solutions Group, and of course, GroupBy, which was an ongoing venture, and I'm very pleased to be able to speak for the first time with GroupBy. So thank you very much for allowing this to take place. Now we do the cool crossfade because I have a completely different color scheme in my slide deck. Who is Randolph West? I'm an author, actor, consultant. I've worked with C#, SQL Server, VB6, VB5, VB4, SQL Server, obviously, and I love chocolate. I needed a sixth thing in the list, and that's why chocolate's there. I work for chocolate. If you've got the good stuff, I will do almost anything for chocolate. My pronouns, as Camille mentioned, are they and them. And if you have any questions about SQL Server or about the session that you're about to see, please email me. That's my email address. It's a cool email address. It's not difficult to remember. and write to me about SQL Server or about anything you read today. I have written some books. Those are the 3 ones about SQL Server. I am an MVP, have been for 5 years. Thank you, Microsoft. I am on the committee for Data Saturdays. There's no sort of board or anything. We're just a loose collective of SQL professionals. That's Data Saturdays that puts on events. We put on the website for people to do that. I'm also on the advisory board of the Azure Data Community. That doesn't mean that I tell the community what to do. The community tells me what to do, and then I go and tell Microsoft along with the other board members. Then, of course, plug Born SQL down here and bornsql.ca there. That's my company. And if you want to find out more, I blog every week, and I have done since November 2015. So let's talk about system versioned tables. Traditionally, there was only one kind of system versioned table in SQL Server and Azure SQL Database, and that was the temporal table. That is our main focus for today. But I do need to mention ledger tables, which is currently an Azure SQL Database only feature. But as we've seen in the past, SQL Server is the boxed product that is released every 2 to 3 years, and features from Azure SQL Database eventually make their way into the boxed product. So we can expect to see ledger tables in the future. But we're going to speak about temporal tables today, but there's 1 or 2 slides where I do mention ledger tables as well, because it's a very neat feature if you're looking for forensics. So we're going to talk about that shortly. So system versioned temporal tables. What are they? They keep a full history of changes to your data. A full history provided you've turned it on. It's not magic. It's not going to invent stuff that you've already not logged, okay? It allows easy point-in-time analysis. So if you type in a particular type of select query with a temporal where clause, or from clause, in fact, to be specific, then you can get information as how the data looked at a particular point in time in the past. That is very, very powerful for reporting purposes. The period of validity for each row is managed by the database engine. So as long as you set up your table correctly to say, well, I want this table to be a temporal table, and I add these 2 columns at the end, which we'll talk about, the specifics, then SQL Server is going to make sure that the date and time is handled for you. That is why it is system versioned. You need 2 period columns. I've just said that. They can be called whatever you like, as long as you have 2 period columns, the start and the end, and they have to be of a date time to data type. So you can have any number of decimal places from 0 through 7 for your date time to. I generally use 3 decimal places because that is a drop-in replacement for date time, and it also uses 1 fewer bytes. So date time, the traditional field, had a 3 or 4 millisecond granularity and was 8 bytes wide. If I use date time 2 with 3 decimal places, I use 7 bytes and I get millisecond accuracy. So that's a pretty cool feature that you might want to think about. Now, system version temporal table, those 2 columns will record the validity period per row whenever a row is modified. So a modification in SQL Server, as you know, is anything that's not a select. So an update, a delete, and an insert. Obviously, if you're inserting into a table, you don't need to keep a record of that row, but it will need a validity period. It's current from the moment you inserted it until sometime in the future. Now, SQL Server is quite smart in this respect. We're not going to be around in the year 9999, so the validity period for current rows is set to that point in the future. It's not set to null because null means unknown. So we try and avoid overloading what null means. Null means it's unknown, but in this case, we know that the validity is current until some point in the future. That point in the future is a known point in the future of the year 9999. System version temporal tables reference a history table. You've got to keep the record of your history somewhere, right? So it's in a history table. It has a mirrored schema. In other words, the columns have to be the same data type, not necessarily the same name, but let's not confuse issues here. And of course, it stores a previous version of the row whenever that row is modified. So updates and deletes, it'll keep a copy of the old row and put it in that history table for you. When should we use temporal tables? Well, I'm of the opinion, being in disaster recovery for more years than I would like, because I've lost data and it's never a good feeling. When you should use temporal tables is whenever you don't want to lose data and you want to be able to go and access data as it was in a point in time in the past. Now, of course, if you're taking regular backups and you don't have some sort of time constraint about being able to access that old data, then maybe temporal tables are not for you. Plus, there is a number of limitations that you need to take into account when you use this feature. Nothing is for free. So when you should use temporal tables, in my opinion, is when you want to, this is my favorite slide in the whole deck, because this is marketing from Microsoft. I love Microsoft. I'm an MVP. I love their products. I've been using SQL Server since 6.5. But this is not true. If you want data forensics, temporal tables are not for you, because data forensics implies a full chain of custody. The problem with temporal tables, which I will show you in the demo, is that you can modify the history, you can modify the current table as long as you have the right permissions, and there's no audit trail of that. So while it is true that you can record data changes in your table, there are ways to get around that, and therefore it's not a full chain of custody. Data forensics isn't possible, but if you have the right permissions and the right auditing, you can keep track of all your data changes in the right way. So marketing, it's a little bit of marketing here. Now this takes us to the new feature that is only currently available in Azure SQL Database, and that is ledger tables, system versioned ledger tables. On my blog, I've written three or four posts about ledger tables. It's a very brief introduction just to give you some idea of what they are. And they provide evidence of tampering during a forensic investigation. Now, this doesn't mean that there's a full chain of custody. There isn't. There's no single way to prove that data hasn't changed unless you have some sort of off-site way of monitoring that. And that's where blockchain comes in. So this is an actual legitimate use of blockchain. I would encourage you to read my blog tomorrow, because I'm going to trash blockchain completely. Ledger tables are one of the few legitimate uses of a blockchain where it keeps a record of hashes of your state of your database. So if you want to get an evidence of tampering of your database, then this is the feature you use. It does keep a record of all the changes by transaction, and you do need to keep that hash or that blockchain off-site. And of course, you can do that using Azure because it's built into Azure. So I just want to make you aware of the fact that ledger tables is a possibility. It's not the same as temporal tables. You can actually use them together. If you want to keep track of your changes, because ledger tables doesn't allow you to make changes to tables, temporal tables does. So you can use temporal and ledger tables together with some limitations. There's not enough time to go through in this presentation today what those limitations are for both features, but I do want you to be aware that it is a possibility. So why would you use temporal tables? I'm going to take a quick sip of water here, because otherwise we'll be here listening to me cough. If there are any questions or comments, please, Camille, let me know. Otherwise, we'll just dive in.
Sure, no questions so far. So you're good to go.
Awesome. Excellent. So why would you use temporal tables? You can reconstruct the data at any time in the past, with a little asterisk saying, as long as you're recording that information, right? You need to make sure the temporal tables are enabled. I know I keep hammering on about this, but in disaster recovery scenarios, people don't have the ability to think clearly, so they think that magic is possible. Magic might be possible, but in this case, you can only reconstruct data from the past if you've been recording it. So it's a very cool feature, and I'll show you that in the demo. You can calculate trends over time. So let's say that you have a monthly report that you have to give to your manager. Instead of having to keep a record in an Excel file somewhere of what the data used to look like, you can just run a temporal query and just pull out the data as it looked at that point in time and just bring it into your graph. It's very, very cool and fast. This is one of the, I put out a question on Twitter a couple of days ago saying, what is your killer feature for temporal tables aside from being able to look at data from the past? And one of my friends from South Africa, James, spoke about, Maintaining slowly changing dimensions for decision support applications. What does that mean? Well, a slowly changing dimension by its name means that there's a dimension in your data warehouse that might change at some point. And when it changes, you could potentially break anything that happened before that change because you're not aware of what that data looked like in the past. So if you want to maintain slowly changing dimensions over time for your data warehouse and other decisions supporting applications, then this is how you would do that, because then you would use that temporal query again to look at what that dimension looked like beforehand. This to me is the killer feature. You can recover from accidental data loss, accidental data changes, and application errors. If an application goes and does something to your data and there's a missing where clause or something like that, instead of having to recover an entire database, you can just go into your temporal history and recover it. That is the demo that I'm going to show you later. And as I said, this I think is the killer feature. So, why temporal? We spoke about application errors. Now, what happens if you turn on temporal tables onto an existing database and you've got select star queries in your reports? Because whether you like it or not, everybody uses select star. I use it in my demos all the time. We tell you not to, but we do it ourselves. So, you know, everybody's got them. Select star is there and it's not going to go away, much as we tell you otherwise. So in order to prevent breakages, if you're using select star style queries and then you turn on temporal tables onto an existing database, you can hide the temporal columns. Those two period columns that we spoke about, you can set them to be hidden, and that way when you do a select star against that table, you will not see those columns. That's for backward compatibility and also to protect yourself against application errors by changing the database schema. Now, history tables can be created manually, or you can let the database engine do it. There's two ways to let the database engine do it. You can either just say, create me a table, and it'll create it based on the object ID, or you can specify the name and the schema. I would recommend letting the database engine do it for you if you provide the name and the schema, because you can create the database in a specific schema of your own making. And then once it's created, you can go and you can change the clustered index that it creates for you and move it into its own file group. So that's very useful if you want to manage your file groups for your history differently to your current data. You may want to put your history data on a slower storage tier so that it doesn't cost as much as your current data, but it is still online. And that might be the workaround for folks who thought they might want to use stretch database and then found how expensive it was. Obviously, as I said, nothing is for free. There are limitations and considerations that you need to take into account when using temporal tables. For example, you need a primary key in your temporal table. You need a way to identify rows uniquely in your current table so that when you go and look in the history, or it writes away to the history, it has a way to identify those rows. You cannot have any primary key in the history table, though. This is the point in the conversation where somebody says, well, that's because you can have duplicates of the primary key from the current table, and that is exactly why. The clustered index that is created in your history table is based on the valid from and valid to columns and nothing else. You cannot have any other constraints either. And that makes sense, because if you're trying to insert data, it's an append-only type of table for the history. You don't want to have any other type of constraints in there, because you may change data in a foreign key lookup. You may change any number of things. So you don't want to have any constraints either. I see that there is a Q&A question, so I'll hand over to Camille briefly.
Yeah, so one question is for data recovery. Do temporal tables work better than transaction log backups?
That is an excellent question. Do temporal tables work better than transaction log backups? As a data recovery expert, I would say nothing works better than transaction log backups. However, you need to test them. You need to test your transaction log backups all the time. Where temporal tables are better is in the amount of time it takes to recover, because you do not have to go and restore your database to a point in time and then go and query the data and then bring it back into your current database. With temporal tables, provided you turned on the feature at the right time and there's no data corruption in your history, you can go and query that table at that point in time and recover the data almost instantly. That is what I'm going to show you in the demo. So that is a very good question. I will always encourage you to make sure that you're doing transaction log backups, because you need to have point-in-time recovery. I will always encourage you to test that. And you may even find that your transaction log backups should be happening more frequently than you think. Yes, you will end up with more files, but you won't end up with more data. I would encourage you to have maybe increments of 5 to 15 minutes of transaction log backups, just so that you have that smaller window for recovery. Because even though temporal tables are very convenient, you may not have enough history to go back to, or you may have corruption in your database, and that would prevent you from doing a recovery from the temporal table history. I hope that answers the question. Is there anything else that people are commenting on before I go ahead?
Yeah, there's another one in the chat window. Can the clustered index in the history table be modified to include the primary key columns as well as the system date time columns?
Well, as I said before, you can create your own table, and as long as it abides by the rules of temporal table history, then you can create whatever indexes you want. But good luck maintaining that, or I don't mean that in a negative way. I mean that you have to maintain that yourself. You have to maintain it yourself anyway, because the history table is going to bloat, it's going to get big, and you're going to have to make sure that if you want to keep that history, you need to move that offline somehow, because it's just going to keep growing and growing unless you tell it not to grow. There are ways to do that in 2017 and SQL database, Azure SQL database, but in 2016, for example, you have to do that yourself. So when I say you need to maintain it yourself, just keep that in mind. As long as you have no constraints, don't have a unique clustered index on the primary key and the 2 period columns, because you could break that contract when you insert a row that has exactly the same date and time, because that is possible. And in fact, keep that in mind, because there's an Easter egg that you need to ask me about in the demo, because I'm going to forget. I have ADHD. So good question. History tables must be stored in the same database as the current table. That makes sense because of the contract between the current and the history table, but that may break your plans to, let's say you want to migrate an audit trail that you've got in an XML style column that you want to bring into temporal tables because that's the new way of doing things. Your audit trail may be in a different database, and that might be a reason for you not to use this feature. You're going to use more space in your current database. That's also why I said if you have a different file group, you can manage that with different storage. But that means that you need to have backups of your history, and one of the mitigations that Microsoft has is to page compress the history table by default. But that doesn't mean that it's not going to take up space and resources. So just keep that in mind. I just said that. The history table is page compressed by default. If you create the history table yourself, you will have to manage that yourself. Again, that's why I said good luck. I didn't mean it in a negative way. I just mean it's something more to keep in mind. If you create the history table manually, you must enable page compression. It's like I'm repeating myself because I think about things and then I realize I have a slide for that already. Now, this is something that also might be a deal breaker for some folks, especially in a SharePoint style database. I say style because I mean things like Project Server, who still uses that. I mean Nav, Dynamics. I mean any kind of database that stores a history of, or version history of files that are stored in binary, or even nvarchar max, or ntext or image data types. Please stop using those if you are. So if you're using these large objects, now blob doesn't stand for binary large object, it stands for blob, and somebody decided in marketing that it was a good idea to give it a reason for existing. Blob is blob, like the movie. So blob data incurs a significant storage and performance penalty simply because it has to take a copy of that old row and put it into the history. And if you've got a 2 gigabyte blob in that column, and if you've got 10 columns that are 2 gigabytes each, it's going to take a long time to write that to the history, and everything has to go into the transaction log. So that's what we're saying here. And if it's page compressed, it's going to try and compress that and fail, and it's still going to take CPU to do that. So if you do have blob data, maybe temporal tables aren't the right approach for those things, or you may want to think about using file table. File table has a whole bunch of other aspects to it that you have to think about, and there are some things that don't work with temporal tables, and that is file stream or file table. So guess what? It doesn't work anyway. Temporal tables don't work very well with blobs, is what I'm saying, so keep that in mind too. Now, when system versioning is enabled, you cannot truncate either of the two tables, the history or the current table, and neither can you modify the history table directly. That doesn't mean that you cannot do those things if you break system versioning, and this is where that whole thing about forensics comes in. If you do have the right permissions, you can break the chain, you can delete the history, you can modify all the data you want and then reconnect them, and unless you're monitoring in defense in depth with an auditing feature outside of that, you're never going to know that it happened unless you're looking at the transaction log. And even then, if I do, well, I do this, then I switch to simple logging, I do a differential backup, you know, all that other kind of stuff. There are ways around that. So keep that in mind too. Here's a QR code if you don't want to remember that link, or if you don't want to search for it and you've got your device open and available, you can go and read up about the considerations and limitations. For my money, I use temporal tables now where I can, but it's not useful everywhere. I'm not going to turn it on everywhere. So, any other questions so far, or are we carrying on?
Now we can continue to go to the demo if
Perfect. Not yet, not yet.
Ah,
You're
not
eager.
yet.
You're
Okay.
eager. There's still more slides.
I am. Yeah, no questions so far.
So managing the retention, I mentioned earlier that the table is going to grow and grow and grow, and eventually you're going to run out of space, because that's always what happens with these things. So in SQL Server 2017 and Azure SQL Database, there is a way to manage this retention. If you're on 2016 or you don't want to use the built-in methods, now please don't laugh, because this is Microsoft's recommended solutions for you. I'm not speaking because I have nothing nice to say about Stretch Database. The other way is table partitioning. Let's say that you want to partition your history table. You're more than welcome to do that because you created yourself beforehand. And then you need to take a maintenance window. You need to break the system versioning. You need to go and then partition, switch in and out, that kind of stuff, and then put it somewhere else, and then continue on, turn on system versioning again, and continue your day. And then you're good to go. You can do a custom cleanup, which also requires you to break the system versioning, go into the history table. Maybe you don't need to keep anything past 6 months or a year because you've got your long-term backups for 10 years. And so you just go in there and you clean it up as you need to. It's just literally a delete statement. But you do need to break the system versioning between the history and the current table. And of course, the built-in feature, which is called the retention policy. So when you alter a table or you create a new table, you can set a retention policy measured in weeks or months, and it will work in a similar way to Ghost Record Cleanup. I say similar because it doesn't use the same actual feature. It works in a way that it will do an asynchronous process and go through the table asynchronously to clean up old records. Now, what's cool, and something that I used to include in the demos, but I don't for this particular one, is that if you do a restore of a database that has temporal tables enabled, it will disable the retention policy. And the reason for that is practical. If you restore a backup that is 3 months old and you have a retention policy of 6 weeks or two or 3 months, it's going to start cleaning up the data. And you don't want that. The whole reason for restoring the database was to go and look for old data. So if you have a retention policy and then you restore a database that has a retention policy on a temporal table, you will need to turn it back on again if you want to continue using that retention policy. That, I think, is a very cool nice thing to know about this, because things could go very badly in a disaster recovery scenario. And if you want to read more about retention, there's another QR code for you, or you can go and look it up in your favorite search engine, DuckDuckGo, which is the only one worth using, and Bing, of course, because Microsoft. I think that might actually be the end of the slides before the demo, Camille. So
great. So it's a great point. To ask one question.
Sure.
Probably you answered that during one of or two of your slides, but let me ask this. What reasons one would have against using temporal tables for auditing when compared with triggers or CDC?
I think that as long as you have some sort of defense in depth in terms of auditing, then you're going to be okay with just using temporal tables, provided you have database level auditing. You can have triggers. You can do. Please be careful with triggers. I'm gonna blank my screen right now so that I can talk to you directly. Triggers are very, very powerful, but can be abused. Oftentimes, when you create a trigger, you might intend to have a trigger operate on only one row, but it is possible, based on the type of data that you're processing, that it may trigger, if you'll pardon the expression, on more than one row, and that could be an unintended consequence, or it could cause unintended consequences. So by all means, use triggers. Triggers are very useful in the right context. In my I have another demo, which I'll coincidentally be doing tomorrow at a different conference, which you can read about on my blog. I don't want to cross promote here, but there is another demo that I do where I show you that you can use stored procedures for keeping a record of your auditing, or you could use triggers. I prefer stored procedures because that's just the person I am, but you can use triggers as well. There's nothing stopping you from using a combination of features to make sure that you're keeping track of who's doing what in your database. What it comes down to is you have to maintain it, and it has to fall within your recovery time objective. If something is too slow, or if your disaster recovery scenario is too slow, or if your auditing is too slow, business is going to say, throw it away, it's not working for me. So you have to balance all of those business requirements along with the technical ones. You can have as many features turned on as you like to monitor your environment, but just keep in mind it's a balance with what the business needs and who's going to keep track of it. Is it documented? That kind of stuff. That was a great question. Thank you for asking. So please use whatever you can. Yes.
One more appeared in the meantime. So you mentioned ledger tables are also not foolproof when it comes to data forensics. Is that just by principle due to something in the database itself is responsible for the forensics, or so could be bypassed by an admin potentially?
Well, an admin can drop a database and then you've lost your database, right? So that's a very good question as well. Anything can be bypassed. What Microsoft is trying to show with ledger tables is that you can prove that something has happened, because there is a method for you to recreate the blockchain. That is a computationally expensive process. It could take hours or days to recompute the state of the database over time. And what that does is, just like your 2 period columns that you have for temporal tables, there's another 2 columns that are added. It's between 2 and 4 columns that are added for ledger tables. And what it'll do is it keeps a record of the hash for each transaction. So unlike temporal, where it's per row, ledger tables work at the transaction level, because that's the smallest atomic thing that can happen in a database. So at the transaction level, it'll go and recompute every single transaction's hash against the previous one, and it'll keep going until it comes to a certain point in time, or the current state. And then it can go against that record of the current state as stored offsite in your Azure Vault, or whatever it is that you're using. In other words, it can then compare those hashes and say, if they're the same, then the database that we're looking at right now, we can prove that it hasn't been tampered with. If the hashes differ, you're not going to be able to necessarily see where they differ, except you'll see where they diverge slightly. And then you'll see the point of diversion. And unless you have another auditing system in place, it may not be possible to see who did what. It is possible to a point where you can see which user ID did it, but you may want other auditing in place to show additional information. So your application tier, your Windows authentication, if you're using Azure Active Directory, you'll need to keep all of the logs as well for that, just to have a big picture of what happened at that point in time as well. So don't think that I'm poo-pooing the whole use of using ledger tables. It's just a proof that something happened. It doesn't tell you what happened in the full picture. You need a full picture by doing other stuff as well. There's a number of ways to do that with database auditing and table auditing and all that kind of stuff, as well as stuff outside of the scope of SQL Server and Azure SQL Database. I hope that answers the question.
Thank you very much. No more questions right now.
Excellent. So, memory optimized temporal tables. All right. Oh, by the way, this doesn't say take me, it just says take me to your data. Memory optimized temporal tables are possible. They're possible. In fact, you've got your current table in memory, which makes sense because that's the whole point of using in memory, and your history table is on disk. However, you need to convert the current row that is being modified into a row that is on disk. And if you know what you know about memory, in-memory tables, you'll know that the data structure is different, which means you need a staging table. And that staging table is also in memory. What that means is suddenly your in-memory table, which already needs 4 times the amount of memory than the actual data being stored, suddenly you need more internal memory for the staging table. And depending on the amount of transactions you've got going through, this could slow things down because, once again, the whole point of having an in-memory table is to have something go faster because it's not going to disk. It's going to disk for the checkpoint files and the logging, but now you've also got a history table that needs to be written to, plus an internal staging table. So it may work on standard edition as well as enterprise, but please don't use in-memory tables on standard edition anyway. You will get a surprise, and the surprise will be a blue screen of death. On SQL Server on Linux, if you use too much memory, the kernel just kills the SQL process without any warning. So it's slightly less bad than a blue screen, but it's the same effect. SQL Server is just going to shut down if you run out of memory. So please, if you're using memory optimized tables in general, take care. Don't use them on standard edition because you'll get a surprise, a nasty surprise. And if you do use temporal tables with memory optimization, you're going to use more memory than you think, and it's going to be slightly slower because of the new history table on disk. So yes, it's possible. Would I do it? No. Now it's demo time. So with any luck, because I moved over to a new computer, if I swipe over, we should go straight into Management Studio. And yes, we do. So that's good. So before I start my demo, are there any questions or can I just hit into it? And please do a time check as well for me, Camille.
Sure, no problem. There's no questions and there's 22 minutes left.
Perfect. We may finish early depending on the questions. So let's see what happens. I have just restored a copy of the Wide World Importers database. All I did is I went to download it from Microsoft's GitHub page and did a restore. Sorry, I say recovery because I do it so much. I did a restore in place so that it can replace itself. And yeah, it took 15 seconds. And now I'm just going to use that database. So what I want to show you in the Wide World Importers database is that it already supports temporal tables. And the reason I'm showing you this is because then I don't have to go through the demo of creating one and showing you how it all works and stuff. Because that's boring. Practical look at temporal tables means let's look at them that already exist and see what we can do with them. So we've got a table here called application.people. If we have a look here, application.people is over here on the left, and you will see in Management Studio, and this works in a similar way in Azure Data, what's it called? ADS, Data Studio, there we go. Azure Data Studio also shows you an icon to represent that it is a system versioned table. So I just wanted to point that out. I'm going to expand that out. And when I expand it out, there's already a history table attached. Now this can be confusing if you're looking at it for the first time. The history table in Management Studio is listed first, and in Azure Data Studio, I believe it's listed second. So if you expand out columns and you're not really concentrating, you'll see that the history tables columns are listed before the current table. So I just wanted to point that out. Application.people has a list of columns here. You'll see that these are all very boring standard columns with various data types. But if we go and have a look here in the current table, you'll see that some of these columns are computed columns. Some of them have constraints. Some of them, there's a primary key. So this is the place where I point out that the current table is as you would have a regular table, but all of those constraints, all of those computed columns have to be regular columns in the history table. And if you want to have a look at the create table T-SQL, I've taken out all the boring stuff about indexes because all I wanted to show you is this stuff at the bottom here. So when you create a temporal table, you need to have two period columns, a start time and an end time. In the Microsoft documentation, they're called sys_start_time and sys_end_time. In this demo, they're called valid from, valid to. You can call them whatever you like, as long as they are datetime2 format. In this example, they've got 7 decimal places, which means that you can have a granularity of 100 nanoseconds, which is a very short amount of time because there are 1 billion nanoseconds in a second. So we're talking about 100 millionth of a second. It is a ridiculous amount of time. It is a very small point in time. And that's the maximum number of decimal places for a datetime2 column. It might be overkill, is what I'm saying.
You can't
Yes?
drink the coffee during that time.
You cannot drink the coffee during that time. You cannot blink. An average human's response time is 600 milliseconds. A Formula One driver at the starting grid is 300 milliseconds. So 100 nanoseconds is a ridiculous amount of time. It's almost useless to even try and have anything smaller than that. Yeah. Count your time in milliseconds, please, because in practical use, that's the point of time you're going to care about the most. But anyway, so in this example, in the wide world importers database, they use datetime2 with 7 decimal places. And what I want to point out to you here is it says generated always. That just says that the system versioning is happening. It's the database engine that is going to enter the times in there. Also worth looking at right there is that the valid to doesn't actually specify the year 9999 that I mentioned because it's the default value. You can specify the default value or you can leave it out. It is a constraint, so there will be a constraint that is created in the back end, but you don't have to specify that information. The other thing that's interesting is row start and row end. So I'm just going to go out of the zoom and highlight it again. So the valid from is row start and the valid to is row end. That's it. It's very simple. Then at the bottom here, we've got with system versioning on, which points to the history table. I will come back to this period column here. System versioning is on, and we're specifying a history table because for whatever reason, you may have your own schema. And in this case, they're using the application schema. If you don't specify a history table yourself, it'll put it in the DBO schema. Makes sense. And in fact, if you've got a partitioned table and you turn on versioning, it's going to put it in the primary partition. So just keep that in mind as well. So because we're specifying the schema name here, we have to specify the name of the history table. So I'm pointing that out to you. And then finally, we're turning on system time for those 2 columns. So we're saying, here are the 2 columns that I'm creating. We're turning on system versioning for them, and we're going to point to a history table that we've specified. It's fairly straightforward. So I'm going to close that because we don't need to look at that anymore. And we're going to actually look at that table. So in this table, I've got the execution plan running here. I've just done a select star. And so in this execution plan, you can see the only thing it's done is it's gone to the main table. It's gone to application.people. and looking at the primary key. It's not looking at the history table at all. And that's important because I'm about to look at the history table as well. When you do a temporal query, you're going to specify the name of the table, the current table. You never specify the history table directly, and you're going to declare a type of system time query. So this is a temporal query for system time, and please bring me back everything. So what it's going to do is it's going to bring back the current table and then concatenate the history onto the end of it, because that's how it's going to pull it out of the database storage. If you want to put an order by column on there, then it'll change the sort order, and then it'll bring it back and put a sort operator into your plan. But by default, it brings back the current table first and then truncates. Not truncates, woof. It brings back the current table first and then concatenates the history table into the end. So let's run that and I'll show you the execution plan. There is the current table, and then it concatenates with the concatenate operator here, the archive, which is the name of the history table. And why have I pulled up this here as an example? Because these are the two random rows that I decided to use during my demonstration. We have two people in the database. One is an employee and one is just a regular customer, Alicia and Agrita. So if we go across here, all the way across, this is from the current table. So that's the row as it looks like right now. We will see the valid from and the valid to are set to particular values. Now, because I restored this from Microsoft's repo, it's from 2016. I haven't done any changes to it. So it's all of this is going to be as late as 2016 and nothing later than that. But notice that the valid to is set to the year 9999, and there was no specific constraint written in the create table, but it is there. There is a constraint and it is set to that value by default. So we've done a select system time query. Now I'm going to do one for those two people. Now this is a slightly different way of writing queries that you might be used to. I did make a mistake and say that it was a where condition. It's not a where condition, it's a from condition that you specify the for system time all. So in other words, you specify your table name, then you put in the temporal part, and then you do the where clause and the order by. So that's something interesting there. And I'm going to run this now for those two people, and I'm ordering it by person ID and validity. Here's the execution plan to show you that it's doing the same concatenation, but then we do a sort. So we're changing the order of the results. So instead of having the current and then the history, we're going to see everything according to person ID and then valid from and valid to. So the history is going to show first up to and including the current row for both people in this database. And you'll see I chose these because they have a number of history items attached to each one. And what you'll notice here, and this is the cool thing, is that whenever a row changes, you'll see that the valid from and the valid to for the next row match. And so that just demonstrates that this is the chain of custody, if you like. As long as nobody messes with the history, this is the forensic data that we were talking about. You can see that at this point in time, this change happened. So as long as you trust your auditing, then you can trust this, but you shouldn't trust it implicitly. Yes. Now what we're going to do is we're going to show you a couple of temporal queries that are slightly different than system time all, because this is going to bring back everything, right? And maybe your history table is quite large and it's going to do a scan at some point because of the tipping point. So we don't necessarily want to do a system time all. We're going to do a system time as of. So as of a particular point in time, we're going to see what the data looked like. This is the one where you can reconstruct data as it was in the past. So as of a particular point in time, this is what those two rows looked like. Now this is a neat trick about temporal tables. If the valid to column is sometime in the past, that means that the record has been changed since this point. It sounds obvious when I say it like that, but it's a neat trick to keep in mind. So that's an as of query. That's probably the one you're going to use the most. But you can also do a between, and you can do from and to. There is a slight difference between and from and to, even though they look almost the same. Between specifies the upper and lower bound, and the from also specifies the upper and lower bound. But just like the between keyword in a where clause, you're going to see slightly different data. The between clause includes the upper bound, whereas the from and to does not. So here you go. When you run the between clause, there's an extra row in the middle here, and that is because the valid from occurs on the upper bound here. So that's the main difference between and from and to. You need to keep that in mind, that it will keep the upper bound when you run a between. Otherwise, they're functionally the same.
I think Daniel have one question.
Yes.
Daniel, do you want to unmute yourself?
Oh yeah, sure, sorry. So I was just musing for myself. Can you use for system time all on multiple tables, or for one out of multiple tables if you're joining tables? Maybe this is far beyond what you're covering. I just thought I'd dig into that at some point.
That is, what do we call that in presentations? That is an excellent question, which means I answer it in the slide of the demo.
Oh, wow. Nice one. Nice one.
So that's an excellent question. Because it's in the from clause, you have to specify for system time for each table. But I'll show you an example of something like that later in the demo. It's a good question. Thank you for asking. So I've shown you from and to, I've shown you between, and now I'm going to show you contained in. Contained in is like having an in clause, an in condition in your where clause. So if you say where ID in blah, 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 it's the same kind of principle here. So your validity period has to be exactly in that period. Otherwise, it's not going to return anything. So and that's exactly what happens here. My system time is exactly these two values, and it's not going to return anything because it doesn't care about the upper bound. So let's now do some damage. Let's actually demonstrate why temporal tables are cool. Now I've written a query that is going to fail. This is intentional. Okay, I want to make that clear. This part of the demo is going to fail because it's meant to. You'll see I've got, what are they called? Redgate has a tool called SQL Prompt, and that tells you a whole bunch of cool stuff. I have SQL Prompt installed. You may not, and you may not have your IntelliSense set up, so you won't necessarily know that this is going to fail in advance. But let's run this and say, whoop, well, we ran that and we failed. So now, accidentally, we're going to run an update query without a where clause. This is the accident. Now, I'm telling you that I've got Redgate SQL Toolbelt installed because it's going to give me a warning. This warning is not always guaranteed, especially if you don't have it installed. So here's the warning. The warning says, hey, you're about to do something stupid. You're about to execute an update statement without a where clause. If you don't have SQL Toolbelt installed or SQL Prompt installed, I would recommend getting it, get your company to pay for it. I pay for it myself. I literally pay every 2 years for a license for myself because of stuff like this. But we're demonstrating people who don't have SQL Toolbelt. So I'm going to run this anyway. I have now run an update on 1,111 rows in the current table, and it didn't warn me. It didn't say, hey, you're doing something silly, except that I had a third-party tool to do that for me. So I want to keep that clear. So now I need to know when that happened, right? So when we look again, what did I do? I set everybody to be an employee. So now the is employee column, everybody is set to is employee. Whoops, that was a mistake. And if we go across to the valid from and valid to, we'll see when the change happened. This valid from column is when the transaction started. So if you have a long-running transaction, if it takes more than a couple of seconds, then this is going to be the point that the transaction started, not the point that it committed. That's very useful if you're doing multiple updates to multiple tables and it takes a little bit longer. Your valid from might not be what you expect it to be, but I just wanted to make that clear. So here's the point in time that this happened. So what we want to do is we want to go 1/100th of a nanosecond before that change, because we know when it happened, but we want to know what it looked like just before. So all I've done is I've copied this into the query and I've said go 1/100th of a nanosecond before then. And sure enough, here we have is employee. Let me just get it here. Is employee is set to what it should be, right? So there's only a handful of employees here. And there was the valid 2. That's when the change happened. So what we want to do is go back to that point in time. And there's 2 ways to do it. The first way is the easy way. We go into the history table, we collect the data that we want, this data here, and we just update the current table. What that means is you will have a history of the event that happened. So your history table is now going to be bigger than you thought, especially if you had hundreds or millions of rows, thousands or millions of rows. So there's 2 ways to do it, the easy way, and then the other way is to break the system versioning and then go and remove the broken history and then reattach the 2 again. So let's do the easy way first. We're going to keep a history of the disaster. So we're going to go and take this value that I got here, and I'm going to say, go and put it into a temporary table for me. And we're going to say select into there, and here's those 1,111 rows. And as you can see, these are the correct ones because of the is employee there. And then what we're going to do is we're going to update the main table, the current table. We haven't broken system versioning or anything here. We're just going to update that, doing a join on the person ID because the person ID is the primary key. We know we're only updating 1 row at a time. So let's run that, and it's going to say, hey, you're doing a silly thing again, but this time we know because we're doing a join. So that is safe to do. And sure enough, there's 1,111 rows that were updated. And if we do a select again and look at the is employee column, which is slightly further along, we'll see there that we're back to the way it was. And there is your valid 2, which is now some point in the future, and the valid from is now, because that's when we made the change. Now let's say, as we fly through the second demo, how do we go about removing that history? Because we want to have the valid from as it was before. And this is where that forensics things comes in, because I'm not going to break all the rules. So if you remember, we have this temporal table here. And I'm going to fly through this because it's this quick, because I wrote the queries already. I'm going to create a transaction. I'm going to turn off system versioning. I'm going to drop the period validity. I'm going to update the table with the old records, including valid from and valid to. Then I'm going to turn system versioning back on. Then I'm going to delete from the history. Yeah, and I just need to fix these as well before I do that. Because remember, if you will, the history contains 2 copies because we went and changed something and we already did that change. So now there's going to be a duplicate copy of the history in there. And then I'm going to turn back on system versioning as if nothing happened. And as you can see, this is a very simple transaction in the grand scheme of things. Oh, good job, Randolph. I have to do it one at a time because I didn't have something right there. Dunk, there it goes. Alter table, add, there we go. Delete from, dunk, dunk. There we go. And the reason it wasn't 1,111 is because we already updated the current table before in the first demo. And then we're going to reattach system versioning, and there it's done. So if you do a select star from these 2 tables, you will not see any record of that history where that mistake happened. So in the people archive, you will see nothing to do with 2020. And if you look in the current table, you will see the previous valid from and valid to. So that's why it's very important to make it clear that unless I was tracking that through some other auditing mechanism, there's no way that I would know, because I was able to directly manipulate the structure of the database. I was able to directly manipulate the data in the history in the current tables, and I was able to remove a mistake that happened. Yes, I had good intentions here, but unless I was auditing that in some other way, there's no way of knowing that. And I just want to demonstrate this now that we've got the system versioning back on. I cannot actually go and drop the table. I'm just pointing that out as a little bit of spice at the end. And I said we'd finish early. I was correct, and it was just a few seconds. So thank you very much for attending. If you have any other questions, we have, what, 10 seconds left. Otherwise, thank you for coming.
Thank you very much, Randolph. Let me double check if we have any other questions.
Can I just say that the first thing I thought of when I saw system version tables a long time ago was, hey, I can use that for slowly changing dimensions in a data warehouse. And then I found out that I can't set the dates manually. And you're saying now I can? So I could build a dimension table and a fact table and then query them for system time this and that much?
You might have to do it dynamically, but yes, you can.
Yeah, I mean, obviously with some dynamic SQL, it'll be messy, but
yes.
But the idea,
it's not. Yes, the idea. It is possible. It is possible. So yes.
Just check my business insurance first.
I'm just going to address Ash's question quickly. Was there a specific need for the use of a global temp table? No, Ash, there was no need. I just prefer global because it's just easier for me to see the double hash. I have visual acuity issues, so it's just easier with a double hash to identify that it's a global temp table for me. So not necessary.
You have the demo and slides in the Git repo or your blog?
I will make these available because the demo script was only finished yesterday. So I will make these available through the correct channels. I do have my previous temporal table demos. They're available on my GitHub repo, but these are slightly different. So they answer a different question, and I'll make those available after we're done here.
Which folder we should looking for? Which repository, I should say.
It'll be github.com/bornSQL/presentations, I think.
Presentations, okay,
London,
cool.
Yeah, London DBA, if I've got time, because I don't want to run over time, so I'll answer this question if Camille lets me.
Another question.
Yes.
What are the cons of adding temporal tables, temporal table to existing table?
The cons are you need to make sure that you don't break any current applications. So you may want to hide those columns. That's the biggest thing. If you want to import history into a history table that you've just created from some other auditing system, that I'll demonstrate in a different demo at a different conference tomorrow if you look that up. But yeah, outside of the scope of today.
Okay, cool. No more other questions.
So London DBA, if you email me or look for me on Twitter and ask that question, I'll answer it there. I just don't want to go over time here.
I believe the next session starts in 27 minutes. So if you want to shoot the breeze or if you want to do demos,
time. Yes.
I will happily answer London DBA's question then. Woo! So today's Tuesday. Suppose I've missed doing my daily raw data load since last Thursday. When I do the catch up by loading the data for Thursday to Tuesday, all of that data will be stamped with an as of day of Tuesday. Anyway, I can do this retrospective data load so that Thursday data is stamped as of Thursday, Friday, Friday is Friday. Only way I can think of is changing the computer system. Or maybe disabling temporal between each day's load. I would just, honestly, if I'm going to do a temporal query with system time, I would just create a temp table with each day, and then just modify the column of the as of in a temp table and just fake it that way. Please don't modify your system date for any reason, because you're breaking the contract with your auditing. You're going to set off alarms everywhere. If you don't have auditing that monitors that kind of stuff, we need to have a chat about your auditing situation. But yeah, don't change your system date to hack a problem with system dates in your data. It's probably better to fake it using a temp table and modify the columns there if that's what you're trying to do. Yeah, just don't change your system date. Yeah. Any other questions? If you want to come off mute, if you want to talk about something else, feel free.
My sick and perverted mind thinks of partitioning. You could probably switch in and out data or something, but that's rocket science territory.
if you're going to be doing any sort of is it DDL, dynamic data language?
Yeah.
DDL. Yes, if you're doing any sort of DL, I never remember the abbreviations. If you're doing any sort of yes, DML and DDL. If you're doing any modifications to the schema of your database, well, firstly, that should be audited. But secondly, if you're going to be doing that with temporal tables, you do need to break system versioning for you, unless I'm going off book. Can I go off book?
We're here for it.
If you were to, this is one of the things about temporal tables that you have to be very careful of. If you have the right permissions, in other words, if you're a DBA, if you have DBO or DB owner or any sort of DDL permissions on the table, you can modify the data type of a temporal table and you won't get a warning. It'll just do it. You can also drop columns from a temporal table and it won't give you any warnings. In fact, let's go off book. Here is our application people, and let's say we're going to minimize the history table here. This is the actual table
share the
we're
screen?
looking at
Are
here.
you sharing your screen?
I will do that now. Thank you for reminding me. Desktop, share. Here I have the application people. It's the same table we've just been looking at. And let's delete the last edited by, which is a foreign key lookup. It's not null. It looks kind of important, wouldn't you say? So obviously it's not going to just let me delete that, but let's go and have a look here and say alter table. What is this? Application dot people drop column. What is it called?
Last edited by. Oh, that's a foreign key as well.
I've got include actual execution plan. And what does it say? It's dependent on column last edited by. So obviously that's not going to work because one or more objects access this. But let's do, I don't know, other languages. Let's do other languages. Other languages. Don't even get a plan. It just did it. So if I go and refresh this on the left here, and we go and expand out the columns, what was it called? Other languages. It's gone. Let's have a look at the history table. It's also gone. No warning. No audit trail unless you're monitoring DDL stuff in your auditing system. If you have the right permissions, you can change history. That's why I say it's very important to know that. That's why I was able to do that deleting of the history of the accident that happened in the demo. But also it is very easy if you have the right permissions. Again, I need to keep emphasizing that, of course. But if you have a rogue DBA, somebody who's leaving the company, and because most of the damage to internal systems happens internally, it's not from external parties. Most of the damage to internal systems happens internally. You've got a rogue employee, you've got somebody who's not happy with things, and they have the right permissions. And between you and me, it is very easy to get escalation of privileges if you haven't patched your environment. If you're running on Windows 2012, let's say, and you've got an escalation privilege escalation attack, 0-day even, and you can escalate your privileges to administrator on the box that is running SQL Server, you can give yourself DBO administration rights to the database, even if you aren't supposed to. So there are ways to get those privileges on an unpatched server. You have to be very careful with your permissions as well, your security, your access. That's why it's not just a SQL Server problem. But if you do get those DBO rights, you can do anything to this data, change it, whatever, delete it, and it's gone. Nothing you can do. I can now go and drop the transaction log history if I have permissions on that as well. So yeah, very important to note. If we have, for example, what's it called? Ledger tables enabled, I wouldn't be able to do a bunch of things because of the limitations. But if I drop the database or I create a new database with the same structure and all that kind of stuff, then the hashes are not going to match. Then we can see that something happened, but we can't see what happened unless we're keeping track of that as well. Make sense?
I mean, in the case with ledger tables, you would have to have a higher permission, not just DB owner. You would have to sort of have the permissions in Azure to do all sorts of things, right?
Right. So it's the same thing if you're setting up, I've forgotten what the feature is called, because even though I wrote a book on it, ADHD is a wonderful thing. There's a thing that allows you to do encryption in-memory encryption in SQL Server. That is like a black box of memory that nobody can look into. When you set up the certificates for that, you need to have two people doing it. You can't have the person who's going to be the DBA as the person who sets that up. You have to have two separate people. Same thing with this. If you're going to set up ledger tables, you cannot have the person who's the DBA managing the ledger table security as well. You have to have two separate people, and you need to follow a zero trust principle. Don't trust anybody, because if you've got two people who can collude, you can do anything. And again, you should make sure that you are auditing as much as you can in whatever way you can. And Jeff points out you have to keep your backups forever. Otherwise, yeah, anybody can change anything and get away with it. Good point, Jeff. Temporal tables won't stand up in court? No, because if you get an expert witness, i.e. me, I can say, I've just demonstrated it. If I have the right permissions, if I have a 0-day escalation that you don't know about, if I get any unpatched server access, then I can escalate to administrator, I can go and modify my permissions, and I can do whatever I like on your server. So no, temporal tables do not stand up in court. And if somebody says they do, you need a better expert witness. Great points.
Randolph, in terms of managing the tables and structure and let's say database projects, so in terms of SSDT in Visual Studio, how this works with SSDT database projects?
I believe that temporal tables are supported in newer versions, and I know that, for example, even in your application tier, so Entity Framework Core supports temporal tables as well. So I'm not a fan of SSDT in that it's a great way to design stuff, but I'm not sure about and this is speaking for me, I'm not speaking against the feature. I don't like the feature because I feel like it doesn't allow for ease of migrations. So if you're doing blue-green database migrations, it might not be the best tool for the job. You might have to write your own custom queries and stuff like that for migration purposes and rollback. Because you should never roll back SQL. If you're rolling back, you made a bigger mistake. You should always roll forward. And I'm not sure if SSDT is the right tool for that, but that's my experience. I'm not speaking poorly of the subject.
I've used the SMO scripting utility at some point, and it doesn't script the hidden keyword. Everything else appears to work, in my experience.
Well, again, the hidden keyword is only specific for backward compatibility. So if you're aware of that, you could have some sort of post-processing thing that goes and looks for that and goes and adds it in or whatever. You cannot rely strictly on a tool. You always have to make sure that it suits your environment. Don't suit your environment to a tool. Always make sure that your tools support your environment. This is a great conversation. I appreciate it. Thank you. I'm just going to take another drink of water, though.
I love this presentation. I'm learning a lot.
I'm glad.
Me too, yeah. Thanks.
There was one other thing I wanted to mention. I'm not sharing a screen, so I can go off into the wilderness and have a look. There was part of my demonstration on the one that I'm doing tomorrow is similar in some respects to what I showed you, where you have to break the contract, the system versioning, and then reattach it again. But one of the things was to do with, if I can find it here. Yes, when you break the contract and you have to re-add your columns, your period columns, and you're loading data into your history table, and then creating a system version contract between the current and the history, and you want to hide those temporal columns, there's a neat trick that you have to do. And I just wanted to find that here so that I could show it to you. Or did I show it now? Let's see here. Ah, yes. So I'm just going to copy this back into this demo here. Go new, I'm going to go V. Whoops. 100%, and then I'll share my screen. Zoom, share screen. Parallels desktop. So can you see my screen again? Management Studio?
Yes.
All right, so you need to, excuse the term because I can't think of a better one, you need to re-anoint your current table once you've backfilled your history into the new history table you've created because you're importing audit from somewhere else. When you need to re-anoint that table and add the period for the valid from and the valid to columns again, and you want to mark them as hidden, it's as simple as, and I say simple, but it took me a while to figure this out. It's simple now for me, is you alter your column, your valid from. You don't have to change any of the database types or anything like that, or nullable or constraints. You have to say add hidden. You can't just say hidden, for example. Does it make sense? You need the add keyword here. So if you're taking a table, backfilling history, and then making it a temporal table based on that old history, and you want to make those columns hidden, you have to say add hidden. That's what I wanted to show you.
Thanks. Great hint.
Yeah. Besides the obvious additional storage space needed for all the additional versioning rows, are there significant performance impacts caused by running temporal tables? That is a good question, Ash. If you have, you shouldn't be querying your history table that much. It shouldn't be a day-to-day thing. If it's a day-to-day thing, you might want to add indexes and things like that. But because it's page compressed, it shouldn't be that bad unless you're doing a system time for system time all. In other words, you're concatenating the data sets from history and current. So if you're not doing that, the performance should be okay. If you are doing a lot of system time all queries, reconsider why you're doing that and maybe do that outside of business hours. So that's a good question. The main performance impact with history, with temporal tables comes with those blob data types that I was talking about. If it's bigger than a few tens of kilobytes, maybe temporal tables are not the right solution for that particular table, and you might want to think of other auditing. That's a good question. I joined late, but I always enjoy the order of revelation, depth of material. Thank you. That's very kind of you. Always like hearing from Jeff. We had some interesting conversations on my blog about date and time. Jeff has a difference of opinion about which is a better data type, and I love hearing different points of view because it helps me learn. And we, in fact, because of a conversation Jeff and I had, we actually corrected the documentation on Microsoft Docs. So I always love hearing from people, especially people who have a different point of view, because yeah, everybody gets to win from that. Awesome. If there's anything else, feel free. If you want to hear from me and you have any questions and you want to send me an email, please feel free. You can see me on my blog. You can see me on Twitter. Lots of things. I don't want to keep people if they want to have lunch because I'm in Calgary time zone and it's probably lunchtime here. So.
No, thank you very much, Randolph. I'm another speaker in this channel, so we test everything before we start. And yeah, let's give people a little bit break before the next session. Thank you very much, Randolph, for a fantastic session.
You're welcome.
Thank you. I enjoyed it.
Thanks. Good. I'm glad. See you.
Take care.
So this day actually just keeps getting more and more terrifying in this track. So first we're looking at temporal tables and how to fool auditors and court cases and stuff. And now we're moving to almost fumbling a $1 million upgrade project. I don't think I have the nerves for this.
Oh, it's been great so far, though. I wish I joined a little bit earlier. I wanted to tell Randolph, I'm like, oh, I could listen to them read the phone book all day.
Mm-hmm.
It was so soothing. I was having a great time. Like literal just listings. I'd be so great for it. But I'm really excited to have have our next session. Just want to pop in and say hi. Really excited for what's ahead, and I'm here if you need anything. And we're just so excited to feature you in a full length session. So it's going to be awesome, Adrian. So best of
You
luck.
say that now. You say that now.
I'm certain. I'm certain. Well, either way, I'll be listening and I'll tell you how much I like it at the end. I'm sure it's going to be great, but really excited. Talk to you all soon. Here if you need me, and thanks for hanging out.